Hello everyone, welcome back to my another video. So it's been a while. I started programming I think like 5 years ago. So I believe you have maybe have some problem with me. So have you ever wondered if your code has a good architecture and design? Is your code Does your code have good coverage in your unit test? How complex is your code? And what is the potential bugs in your code? And are you complying with some standard formatting standard for the language that you use? So that's a I think every developer question about his own question. So today I would like to share with you how I am going to investigate and find out and check the quality of our code using SonarQube. So with SonarQube, you can check your architecture and design quality, your unit test coverage, your duplication of code, code complexity, potential bugs, and some of the compliance of the Kony standard. And the best thing is it support multiple programming language. For now is 27. So one of them is Python, and my recent programming is using Python for especially for Tailor AI. So that's why I'm going to scan my implementation for Tailor AI using this SonarQube to refine the code for better visibility, so better quality. So this is the SonarCube component overview. Very simple. We have our code here in Python, and then we have a SonarScanner. SonarScanner is an agent that will scan our code and then publish the result to the SonarCube server. And then this SonarCube server will display the code coverage, the code complexity, formatting, some potential bugs inside here, and save inside this data, store the SonarCube scan results. So you can see that maybe some of you not familiar with Docker. So a bit while I will explain to you Docker. So you can see that this SonarQube server is placed inside a Docker. So it means the SonarQube server is a Docker, one of the Docker container, and this Docker is running on host PC, which I'm using right now is Ubuntu. So what is Docker, and how are we going to utilize Docker for SonarQube server? So a Docker is a tool designed to make it easier to create, deploy, and run application using container. Fair enough. This is the host OS. You can choose like a Linux. It support multi-platform. Linux, Windows, and Mac OS also capable of handling this Docker engine. And inside this Docker engine, you will have multiple Docker container, they call it. So each container have their own isolated development environment. So which means if you install container A, CMake version, CMake 1, for example, 1.0, then the container B is CMake version 2.0. So it won't collide with anything. So it run independently inside the container itself. So you can check out the link I put here. I will share with you the slide. So this is where we put our SonarQube server is as one of the Docker container. Luckily for us, in Docker Hub, there is SonarQube server image already, so we can utilize that. You can check out here. So we can just we only need to Docker pull SonarQube, then we will have the SonarQube. Then when we run the SonarQube server is up, then we can scan our code, then publish the result, and then we can start seeing it. So first, before that, we need to install it first, right? So to install the Docker, you need to go here. And this is especially for Ubuntu. Also got some option for CentOS, Debian, Fedora. So this to install all version. For me, I already installed it. So I'm just go through here. First, you need to uninstall old version if you have any to make it more clean install. Then you update. Then you install this package. Then official GPG key. Check the fingerprint. And then add repository. Update again. Then after that, you install Docker CE. Docker CE CLI container.io. And then that's it for Docker. Once it has been installed, you can check like this command, which Docker. So if it's installed correctly, you can the result will be something like this. Or you can check your Docker version. Okay, so 19.03.12. So now we have our Docker. Now we need to pull the SonarQube server. So to do that, we only need to copy this and then paste here. Don't forget with the sudo command. It will pull the latest SonarQube image. Okay, since I already pull it, so I'm just update the image. Okay, we know that SonarQube server will store its information in this directory opt/sonarcube/data. You can check out here. So this is the volume that the SonarQube Docker container use. Data files such as embedded H2 database and also Elasticsearch index and also some configuration. So, but this is where our interest to be. So what I'm going to do is I'm going to bind this volume to the folder that placed inside my host PC or Ubuntu. Why I need this? Because in Docker, so this is container A, B, and C. Every time you restart a container A, mean you power off and you turn on again, it will lose all the memories about the previous state of condition that you have been done inside it. So for example, if we run our SonarQube, if we run SonarScanner and then publish the result to SonarQube server, if we not bind the volume, then after we restart the server, since we run it locally, it will lose the information and we can see the graph where our code being improved. So that's why we need to keep that data. So to do that, I will show you later with the volume command. Okay. Okay. So for that, I already put it here. So to run, you only need run docker run -v. Before that, we need create a directory. I like to put the directory here. opt sonarcube/data, the same one. Oops, so I forgot. Sudo make opt. Oh, opt already exists. Then sudo make directory opt cube, and then sudo make directory opt sonarcube data. Okay, so just check SonarQube and data is available. Okay. Now I'm going to run sudo docker run -v, which I want going to bind the volume. This is the local path that I want where I want to mount the volume, and this is targeted path. Since I'm using the same path, that's why it's a same. But this here is referred to my where is my location in my host PC that I'm going to bind the volume, and this is the location inside the container where I'm going to get the volume, get the data is. And then I'm going to run it at port 9000, and then the SonarQube image. The SonarQube when I pull sudo docker pull SonarQube, the image name will be SonarQube. Okay, so if I run this, it will display the SonarQube server as mentioned here at port 9000 for my at my local host. Okay, I think we can check. So run here 9000 and then log in. So the login to SonarQube is for the basic one is admin and the password is still admin. So you can log in. And then the first step you need to from here this is the SonarQube dashboard. So you can see that you have no project whatsoever when you first install it. So what you need to do is create any project. So my project is name N450 and I will generate it. This is the token so that only application that have the same token will publish this SonarQube dashboard. So continue. I'm going to run my project. Main project is a Python and OS Linux. This is the Sonar scanner for the Linux. You can download it, and this is the path. This is the configuration when we're going to build the Sonar scanner. So I have downloaded the SonarScanner. If you download here, yep. For Linux, you can click Linux. For Windows and Mac OS, you can click here. So this command will run the SonarScanner and scan your code and publish to this result URL, which is here. And then this is a project key and this is the login. But this is to be run using CLI command. So for future, for better visibility, perhaps we're going to keep it inside a file so that we can only using that file to run the SonarScanner. So for that, I'm going to create a new file later on. So before that, we already create our uh, project here, N450. So I'm going to create this is my N450 project for the Telo AI. I'm going to create a new branch. I put it under bug fix. I create uh, refinement code implementation. I create the bug fix, and then I'm using Sublime Merge to pull it. Create local branch. Okay, here I am. So this is the code. So I'm going to create a new file. I call it Sonar properties. Sonar project dot properties. So inside here, I'm going to copy all of this. But the configuration can be so I call it SonarScanner configuration file. Okay. The Sonar project is N450. The source is here. This is the path URL, and this is Sonar login. So this Sonar login is actually paired with the N450 project key. So okay. So remember that we need to download the SonarScanner first. Okay. SonarScanner is, if you remember, the one of the agent that will scan our code and publish the result to SonarQube server. Now SonarQube server is published, but no analysis been made. Okay. So we need this SonarScanner. I already downloaded SonarScanner to here. Okay, so what I'm going to do is I'm going to open the terminal and I put it under download SonarScanner. So what I'm going to run here is download SonarScanner bin SonarScanner. So when I run this, it will scan all the code inside this path directory. And the time to compute it is depend on how big your code size is. Okay, so the analysis total time is 8.5 seconds and the execution is success. Okay, so if I refresh here, I can see all my code, the vulnerabilities, code smell, coverage, duplication is published here. If you go inside, you can see there's a 55 code smells in my code, 6 security hotspot, 5 hours and 5 minute technical debt. Means how many hours do I need to resolve this code smell and this security hotspot. Okay, so you can see inside the code smell more detail. So you can see the severity of it. Okay, the issue. One got a blocker. So refactor this method to not always return the same value. Yes, I did have inside this image processing um, method where I always return the post process even though they got a if else condition. And even though it's not enter any of it, it will return the post process. So this is kind of potential bug. You can see why this an issue button here. You can click. So if you read, when a function is designed to return an invariant value, it may be poor design, but it shouldn't be obviously affect the outcome of your program. Okay, so it can potentially be a bug. So for example, if the image processing is not entering any of this, but it's still returned to the post process. So the flow is correct, but somehow this does not show the good concept of design. Okay, this is one of the example. You can see more on the critical, for example, here, the cognitive complexity. So the cognitive complexity is how many if and else statement you have inside your code. So if, for example, this is plus one, this is plus two. So if you have another if inside your if, and inside that if contain another if, so the complexity become incremental by plus one, one, and then plus two, and then plus three. So it become more complex. Why it's complex? So you can see why it is an issue. Cognitive complexity is a measure of how hard the control flow of a function is to understand. So which means if you have multiple if inside an if, so it will be difficult to predict what is the output of your function. Perhaps your function is too big or too large. But same as I said, if I change this, maybe if I refactor this, I need to do some more retests on my code to make sure it works, and maybe redesign the architecture as well. I'm more interested to solve the issue with some typo, some naming convention, some minor things, so that uh, I can ensure the existing code is still working. And when I want to create another fresh new project, perhaps I will design a more better solution. So here you can see rename this local variable underscore magnitude a to match regular expression. So this naming convention is not complying with these rules. So that in Python, I know that the camel case is not like recommended. It better if you use like magnitude underscore a, and it become all the lowercase. You can see here all the lowercase. So this is the Python things. So this what I'm looking to improve. And then same here, YP. So this is the control system uh, state where I do the object tracking. And okay, for example here, remove the unused variable count. Okay, sometime when you create a variable, sometimes you forget about it and not use it, not utilize it. So this SonarQube able to find it, and then I can easily remove this. Okay, this is major. Yep, that's it. Okay, for here. Replace this is operator with. I tend to use like this if direction is front, but turn up that for comparing uh, is only for being used for recommended being used for if the to compare the type. For example, A and B is the same type of object, so you can compare using is. But if you compare with some number, string, value, integer, you need to use this equal things. So to make it compare based on the value. Okay, you can read here integer, byte, float, frozen set should not be compared with identity operator because the result may be not as expected. So here it is. We can see this is 5 hours, 5 minute technical debt. So here you can see the technical debt here inside this state. Uh, the red color here means it's not covered by test. If you not do any unit test in your code, then it will label as red. And if it show the symbol here, means got that some issue. For example, this define constant instead of duplicating this literal state 8 times. So this is like a string only. Okay, and some other, for example here plan.py script. Yeah, this is the name. So it's much cleaner than if we view the code smell here. It become so many things to see. If you click here, it's much easy to view. For example here, what's the problem with this? Rename field stream. Why this an issue? So this is because the my file name is stream.py and my object name is stream, and also the inside it I also got instant call stream. So it's confusing to have a class member with same name as in enclosing class. So it's better to change it. Okay, that being said, I think it's ready for us to start improving. Okay, So let's see first where I'm going to fix it. Let's see, measure 5 hours, set the PY. Okay, so I don't want to do anything here. No, I don't want to fix that. uh, Object quadrant, remove the assignment of local. The value is never used. Okay, why is never used? Because it this object quadrant will always replaceable by any of these. You see, there's got a conditional statement here. So if, elif, and else, the last one else, it will replace the object quadrant whatever I place here. So this is like nothing to do with here. So I'm going to change the state number 371. So I open the file state 371. So here, object quadrant. Okay, so if I edit here, will it exit? All right. And then next, update state from mode. Okay, so you see here, I already install the extension of a SonarLin. So you can install it. So SonarLin and SonarQube is the same company coming from the Sonar source, which from here you can see the same checking result is been run inside here. Okay, so it's much easier instead of we just cross check with this dashboard to find where our code smell. So I'm just using this, and from here if I hover over it, refactor this function to reduce its cognitive complexity from 22 to 15 allowed. Okay, nothing I want to do here yet, but what I can do is okay, state. I can see the code duplication here is so many. This is literally the same as here and here and here, the same one. So maybe I'm going to change before it exit. And then I'm going to return. For this, I'm going to change return state error. State error is equal to, so I just change here everything. So state equal to exit. Okay, and we don't need this anymore. Last state equal to last state. Let's click here, 1, 2. Okay. State error. Okay, log the changes. Yep. So from here, I reduce the duplication of my code and just comment here. And then return the state and error. So this is still do the same thing. Instead of if they enter here and then return and then got a multiple return inside this method, instead I just keep the value state error equal to object, and since I don't have else, I need to create here perhaps idle and then none. Okay, so log for every state changes. If last state not equal to state, log info equal state format state. Okay, last state, and then return the state and error. Yep. Okay, next. And then here the frame.jpg is a duplication. It's called 3 times. So maybe I can rename this to something. Because of frame.jpg, I will replace with image underscore name. Okay, so now I only declare once the image name. Okay, next. So here either for this is the nesting. I don't want to handle with nesting for now, since if when you change, if you try to solve the complexity of your code, uh, if you not take care carefully, sometimes the result of the method that you plan to have can be changed, so you need to change it carefully. Okay, next. Object track, this one same. Okay, uh, but this one, rename this local variable xp to match the regular expression. So here, maybe I can change it. I need to find it exactly, match case. Okay, and got the many two. So I'm going to change to xp, um, what do you call it, PID KP, the gain of x time with the x difference. So XP value, XP value, and then this XD I'm going to change to XD value, and then what else? This YP same, I'm going to change to YP value, YD value. I'm going to change to YD value, YP value, YD value. Okay, and then same ZP value, then this ZD same, to change ZD value. Okay, seems like it. Alright, so the pass track, what happened here? Got some nesting too. Okay, this one. Merge this statement, if statement with the enclosing one. So since it's only have one, so but I don't want to change this. Okay, this is for the pass tracking mode. So okay, next. I'll change same here. Okay, this is a manual control. Okay, see, remove the assignment to local variable direction. This value is never used. So why is never used? Because I got the if and elif here, but then I got another if condition statement here, and then at the end of it got the else. So the direction value will be override, even though if it, for example, if it enter here, then at the end of this, the directions before I log or do anything with the direction variable, it already replaced with stop. So for that, easy, I just put it else if here and then enclose it as one. The direction takeoff, right? So every time I only run takeoff and it will store the information, it will jump to here. This one, merge this statement if with the enclosing one. So if health says press, so what I can change here is and combine it. Yep. Okay. So I just format selection. So let's see what I've changed. So I will stage this and I put add refine state machine. Alright, and this is Sonar project properties. I also want to commit first, so add Sonar project properties file. Alright, so next I want to see, okay, state I think done. Let's see tailor raw command.py. What happened here? What is the most interesting one? Okay, here is what rename this variable. It shadow the built-in. Yes, in Python got the minimum function. It's a built-in function. So I'm going to find this command.py under tailor raw, and then minimum. So I'm going to change this to minute. And what else? So this command here, what is error? Define a constant instead of duplicating literal command 4 times. Okay, I don't want to change that. Um, Remove this commented out code. So what I'm intended here is just to remember what is the data 9. If log header message is coming, what is the data that I'm going to get. So I just put it as like this. Okay, data 9 and data 10. Okay, what else? This one here, either remove or fill this block of code. So I'm just change as a comment placeholder. Um, because maybe I'm going to use it later on, but for now I'm not filling it with anything. Do something. And here is a, yeah, replace this is with the operator equal. So here I will change this everything to equal. Ah, change to equal. Okay, next. Everything good. Process packet. What happened here? Okay, the complexity only. Okay, format the selection. Okay, all right, so refine. Stage it. um Replace I with underscore for not being used. All right, okay, X seconds. So if I go overview, now it's much more better. It's got a 13. I just resolve one. Okay, so this is the issue. Okay, just double check. Security hotspot, weak cryptography. This is the info. I'm not using it yet inside my code, and I just put it random here just to test the plotting the sensor data. But now I'm not completing it yet. So this is a measurement. You can see the reliability. The rating is A, security A, review. Overall, the security hotspot is E, not that good. Okay, coverage is 0. Line to cover is 1888, but I'm not cover any of that. Duplication is 0. The size, new lines is 96. Total line of code is 3400. Complexity, cyclomatic complexity is 359. So this is not that good. This can surely can be improved later. And got some issue. Still got the issue with the uh, some of the file. And this is the code. How many line of the code? How much the coverage? and the activity. So from here, if you running this again, you can see your code improvement time to time. Okay. So this is fail. So instead of, because I'm not interested to put the unit test in the Python code for now, so I'm going to do, I'm going to set the quality profile, no quality gates. So I'm going to create a new quality gates. Okay, this coverage. So I will create, copy here. I will create it as robot way, copy. So inside here, I will delete the coverage. And for the quality profile, sorry, projects here, what is name, quality gate, I will change to using robot way. So if I rerun this, now it passed because it's not checking for the unit test. Okay, even though unit test is 0. So just for the sake of the green color. Okay, so but I still have another 2 hours and 7 minutes to resolve. But still, since I don't plan to make it, so I just leave it as is. So here you are. I think that's pretty much everything to improve your code using SonarQube tools. So as you can see, and I willing to have this SonarQube to run in Docker is very straightforward, simple enough, it's free of charge. So I think this is the best tool ever for me to to check if my code got some issue. Okay, so I think that's all for today. Hope you guys check it out, this SonarQube, and I will put all of this link in my description below. Keep watching and thanks for your time. Bye.